Welcome back to our discussion on for loops in Java. In this lesson, we'll explore additional ways to use this looping construct to write better Java programs. After completing this lesson, you'll understand how to use for loops in various situations effectively. You'll also know how to use for loops to sum terms in a series. Moreover, you'll recognize how to make for loops count down rather than count up. Finally, you'll be able to identify some common problems that can occur with for loops in Java. In the previous lesson, we examined the for loop statement that allowed us to repeatedly execute some code a set number of times. After performing the initialization, the loop condition was evaluated. If the condition was true, a set of statements was executed, followed by the loop update expression. As long as the loop condition was true, the body and update expression were executed. Once the loop condition was false, the loop was exited. In that lesson, the for loops that you saw all use the loop counter variable in the body of the loop in some manner. But that is not a requirement. We might just want a for loop that repeatedly executes some code, but that code does not care about the value of the loop counter variable or which iteration of the loop is executing. In this simple example, we use a for loop to print the word love a specific number of times. Another use of for loops is in computing a series. In mathematics, a series is the sum of a sequence of terms. They are used to compute various special mathematical functions and constants. We use similar loops for computing all sorts of results. They are so common we give them a special name, cumulative sum loops. Such loops start by initializing a variable that will act as our accumulator. Depending upon what we are summing, the variable could be of type int, double, or even string. The for loop is then written to iterate over the desired range of values, and the body of the loop adds the next term of the series into the accumulator. When the loop exits, the accumulator variable will contain the desired result. Here, in this example, we have a cumulative sum loop that is computing the harmonic series, which is the sum of 1 plus 1/2 plus 1/3 plus 1/4, etc. And the for loops are not restricted to starting at 1 and counting up by 1 each time. Here you see a loop that starts at 2 and doubles its value on each iteration, stopping when the value passes 2500. This loop adds those values into an accumulator named sum, thus resulting in the summation of all the powers of 2 between 2 and 2500. You can also have loops that count down rather than count up. Here is an example of a for loop whose loop counter variable starts at 5 and which is decremented by 1 on each iteration. This loop continues executing as long as the loop variable is greater than or equal to 1. You need to be careful to modify your loop test correctly so that the loop continues as long as the loop counter variable is larger than some target value. As can be seen, this loop will count down from 5 to 4 to 3 to 2 to 1 before finally exiting the loop. Finally, as you write your for loops, you should be aware of some common problems. One such problem is writing a loop that executes 0 times. Here's such an example. You see a for loop whose loop counter variable I starts at 10, but the loop test says while I is less than 5. But since I starts at 10, the loop test is false before the loop even begins to execute. As a result, the body of this loop is never executed. And worse than a loop that never executes is a loop that never quits. Here's a for loop whose loop counter variable starts at 1, and the loop test is while I is less than or equal to 10, which is true, and thus the body of the loop is executed. But when you come to execute the update expression, here is a common mistake. You see we have a post increment expression combined with an assignment operator. When this executes, the expression on the right hand side of the assignment operator is evaluated. This is the post increment operator. Thus it increments the variable I, changing it from 1 to 2. But since it is a post increment operator, it returns the original value of I as its result, and that is the value 1. This value is then assigned to I on the left hand side of the assignment operator, changing I back to 1. The end result is that I did not get changed. And as a result, I will always be less than 10 and the loop test will never fail, and thus this loop will execute forever. We call this an infinite loop. Another common problem is typing a semicolon after the for loop header. This semicolon forms the body of the for loop, resulting in an empty loop body. The code in the curly braces is not the loop body in this case, and will only get executed after the for loop is done executing. In this example, the for loop will repeat 10 times, but does nothing on each iteration. Only after the loop exits will the println statement in the curly braces be executed. This lesson explored various ways to use for loops to write better Java programs. Now that you've completed this lesson, you should understand how to use for loops correctly in a wider variety of situations. You should also know how to use for loops to sum terms in a series. Moreover, you should recognize how to make for loops count down rather than count up, and be able to identify some common problems that can occur when you use for loops in Java.